Welcome to part 2 of the Module 10 review. We're going to continue on just doing this now. Once again, these have like bases. We're multiplying two things with like bases, the base being 4x. We have 4x to the 20th and 4x to the 5th, so when we're multiplying like bases, we add. So we have a 4x to the 20 plus 5, or this is a 4x, and this should all be in parentheses, excuse me, to the 25th power. Okay. Now here, we're going to multiply like bases. We don't have the same thing, but we can multiply the m's. That is m times m to the 5th, and n to the 5th times n to the 6th. Because there's an implied 1 right here, we add these up. M to the 5th times m to the 1st is m to the 6th. Here, n to the 5th times n to the 6th is n to the 11th. So that's what we have here. Now, here, when we're simplifying these right here, generally what I like to think about is, are there more t's in the numerator or denominator? Well, they're in the denominator, so we'll end up with t's in the denominator and a 1 in the numerator. Now, 2 of these take care of 2 of these, leaving us with 4, so we have 1 over t to the 4th power. That's what we can do there. Now, 11x to the 12th divided by 11x to the 12th, if we use the rule of exponents, that would be 11x to the, we subtract when we divide, just like we add when we multiply up here. That'd be to the 12 minus 12, which is 11x to the 0th, which is 1, which is the same thing we'd get if we just canceled these, because you can cancel the same things here. With number 19, I'm going to make everything positive before we mess around with it. So I can make this p to the negative 6 positive by moving it up. So we have p to the 4th times p to the 6th here. Multiplying like bases, add the exponents, that's a p to the 10th. So we have that here. And then finally here, same thing. I'm going to make all my y's positive. So we have our y to the 3rd that stays positive, but this y to the negative 13th, as long as we bring it down, that's going to be good. So we have a 1 over y to the 16th power, because we're adding the exponents when we multiply like bases, and that's how we do that. So moving on to this next set, here, when we're raising this to the 3rd power, we raise each of these things to the 3rd power. So we're going to have negative 4 to the 3rd, we have x to the 6th to the 3rd, and we have y to the 3rd. Now, negative 4 to the 3rd is negative 4 times negative 4 times negative 4, that's negative 64. If we have x to the 6th to the 3rd, when we raise something to a power that's being raised to a power, we multiply, so that's an x to the 18th. Then this is a y to the 1st to the 3rd, multiply those, and we have a y to the 3rd. With this right here, I'm going to make all my exponents kind of positive before we do anything else, and I'm going to do that right over here. So one thing we have is that negative 5 on the outside is just outside there. Putting a division bar, like that division bar we'd have right there. Now we can make this y to the negative 4th positive by moving it down, and the y to the negative 1st positive by moving it down, but that's going to be canceled out by this y to the negative 6th. So first I'm going to use this outside exponent to bring these down and say we have an x to the negative 4th, y to the negative 1st, all to the 6th. Okay. Second thing we can do is I'm going to apply the exponent to each of those things. So if we have negative 5, if we have y to the negative 4th to the 6th, we multiply those because we're raising something to a power to a power. So you have x to the negative 24th. Here we're raising something to a power to a power. So we have a negative 1 times 6, so we have y to the negative 6th. Last thing is making these positive. We're going to move them up. So for number 22, we're going to have our negative 5. We're going to have our x to the 24th, which is up now, and our y to the 6th, which is up now. So that's what we want to do there. Now here, we're raising all these things to the 4th power. So negative 4 to the 4th power is negative 4 times negative 4 times negative 4 times negative 4, which is 256. So you have 256. Now if we have p to the 5th to the 4th, we're multiplying those because we're raising a power to a power. So you have p to the 20th. Q to the 5th to the 4th, multiplying those, so we have a q to the 20th, and raising r to the 5th to the 4th, raising something to a power, so that's going to be an r to the 20th as well. So that's how that works. Here, we can cube the numerator and denominator of fractions, so this is going to be a 5 cubed over a 2y cubed. Now 5 cubed, 5 times 5 times 5, that's 125. Y cubed, well, we can cube the 2, so 2 times 2 times 2 is 8. Y cubed is Y cubed, so that's what would go in here. Same thing with this next one. If we cube this 5a, we're cubing the 5, which is 125. We're cubing the a, which is an a cubed. We're cubing the 2, which is an 8. So that's what we have here. Number 26, we're raising things to powers that are being raised to power. So here, if we raise x to the 4th, when we're raising something to a power that's being raised to a power, we multiply, so that's going to be an x to the 16th. We also have to raise y to the 4th to the 4th. So to the 4th, we're raising something to a power that's being raised to a power. We multiply, that's a y to the 16th. And then we have to raise the z to the 6th to the 4th power. Multiplying again, that's a z to the 24th. So we get our x to the 16th, y to the 16th, and our z to the 24th. Now, this next one, I'm going to move this over and do a little bit of work to the side. This next one, remember that if we have a negative exponent here, we can flip the fraction on the inside and make that positive. So we can say this is a 3 over b to the 5th to the positive second. So that would be implying that we could make this a negative exponent and this a negative exponent and flipping those to make that positive. Now we're squaring this. 3 squared is 9, so that we're going to have a 9. When we square a b to the 5th squared, we're multiplying exponents because we're raising thing to a power. So we have b to the 10th. That's what we have there. Same thing with number 28. We can make this something to the positive third, but we have to flip it. So w to the third comes up, our z comes up, our x and our y to the 6th goes down, and this is all to the positive third power now. Now that we have that, because we're raising things to a power, when we cube w to the third, that's going to give us a w to the 9th. When we cube z, that's just z cubed, divided by. When we cube x, that's an x cubed. And when we cube y to the 6th, multiplying exponents, it's a y to the 18th. And then finally, putting this number in scientific notation. Scientific notation, we want the number to be between 1 and 10, so we have to move the decimal 2 spots over. So that would be 8.0199 times 10 to the... Now, when this is a big number, we're making it smaller. This is getting smaller, the exponent's getting bigger. We move it over 2. That's the second power. So that's that one. So next time we'll pick it up at page 3, and hopefully I can keep working on this, and it's not too small or creating too much of a mess or too hard for you to read.